In this video, we're going to talk about repetition structures, that is, ways to repeat ourselves. We often have to write code that performs the same task again and again. And without any sort of looping mechanism, we have to duplicate our code. It makes the program time-consuming, large, and you just might not be able to do certain things. A repetition structure makes code repeat, and the included code is necessary. There are condition-controlled loops and count-controlled loops. The while loop, so think about it this way. A while loop is basically, in English, while something is true, do something. It has two parts, the condition, which is tested for true or false, just like if statements, and statements which are repeated as long as a condition is true. In a flowchart, the line goes back to the previous part. So the general format is while condition is true, do these statements. So we enter the condition. Is it true? Yes, do our statements. Is it true? Yes, do our statements. If it's false, stop. In order for a loop to stop executing, something has to happen inside the loop to make the condition false. An iteration is what we call one execution of the body of a loop. The while loop is known as a pre-test loop because we test before entering it. Test conditions before forming an iteration will never execute if the condition is false to start with, and it requires some steps before starting the loop. Here's a general flowchart. Let's start. We'll have a Boolean y. We'll say assign y to keep going. Is keep going to yes, true, then prompt the user for all their stuff, display the commission, and repeat until the user enters no. Loops must contain within themselves a way to terminate. Otherwise, you will get an infinite loop, and that's a loop that doesn't stop. It repeats until the program is interrupted, and it can go forever. It occurs when a program forgets to include stopping code, or in very special types of programs, like operating systems. The other type of loop is a count-controlled loop. It iterates a specific number of times. For this, we use a for statement to write count-controlled loops, and it's designed to work a sequence of data items, so not just counting. It iterates once for each item in the sequence. The general format is for variable in value 1, 2, etc. And then do the statements. The target variable, the variable which is the target of the assignment at the beginning of each iteration. So here, for num in 1, 2, 3, 4, 5, each time through up to 5, for each item in this list, it'll take the value like num and put 1 and put it in num, and we'll print that out. The second time through, it'll put 2 in there. The third time through, it'll put 3 in there, 4 in there, and so forth. The range function simplifies the process of writing a for loop. Range returns an iterable object. An iterable contains a sequence of values that can be iterated over, meant run through. Range characteristics, one argument used as an ending limit. You can have 2 arguments using as a starting and ending limit, or 3 arguments. The third argument is a step value, as in increment by 2. So the purpose of the target variable is to reference each item in a sequence as the loop iterates. Target variables can be used in calculation or tasks in the body of the loop. Example, calculate the square root of each number in a range. Sometimes the programmer does not know exactly how many times a loop will execute. It can receive range inputs from the user, place them in a variable, and call the range function in the for clause. Be sure to consider the end cases. Range does not include the ending limit, so it includes up to but not including. So we can generate an iterable sequence that generates from highest to lowest. The range function can go the other direction. We make sure the starting number is large and the ending number is smaller, and now the range can be negative. Start at 10, go to 0 by step -1. So programs often need to calculate a total of a series of numbers. Typically, this includes 2 elements: a loop that reads each number in the series, and an accumulator variable, which accumulates the value. It keeps a running total, accumulates the total, and reads in series. At the end of the loop, the accumulator will reference the total. So we set our accumulator to 0. Is there another number to read? Yes. Read the next number, add it to the accumulator, and continue until we have no more numbers. In many assignment statements, the variable on the left of the equal operator also appears on the right side of the operator. Augmented assignment operators are special sets of operators designed for this type of job. They are shorthand operators. We have plus equal, which is equivalent to x equals x plus 5. Minus equal, which is equal to y equals minus 2, multiply, divide, modulus. You can do it for pretty much any numeric operator. A sentinel is a special value that can mark the end of a sequence of items. When the program reaches a sentinel, it knows that the end of the sequence of items is reached and the loop terminates. It must be distinctive enough so as not to be mistaken for a regular value in the sequence. When reading an input file, the empty line can be used as a sentinel. Input, the computer can't tell the difference between good and data and bad. You have to provide logic for that. If the user provides bad input, the program will produce bad output. It's called garbage in, garbage out. It's important to design a program such that bad input is never accepted, or at least notified. Input validation loops is inspecting the input before it is processed by the program. If input is invalid, we prompt the user to enter the correct data. Commonly, this is accomplished using a while loop, which repeats as long as the input is bad. The input is bad, display error messages, and receive another set of data. The input is good, continue to process. We get our input. Is it bad? Yes, display an error and get it again. Try it again. Is it good? Is it bad? No, then continue on. You can also nest loops, a loop that is contained inside another loop. For example, an analog clock works like a nested loop. Hour hands move once for each 12 movements, and the inner hand moves for each 12 iterations within there. 60 within there. So here's a nested loop. Is there another value in the list of hours? Yes. Assign the next hour to the hours variable, then continue. Is there another value in the list of minutes? Yes. Assign the next minute. Is there another value in the list of seconds? Yes. And so forth. This would be a triply nested loop. The key points about nested loops. The inner loop goes through all of its iterations for each iteration of the outer loop. So it gets very expensive. Inner loops create their iterations faster than the outer loop. And the total number of iterations in a nested loop is the number of inner loop times number of iterations of the outer loop. So typically it's called an n-squared loop. So we covered repetition structures, including condition control loops, count control, and nested loops. There are other types. Infinite loops and how to avoid them, the range function, calculating a running total, and augmented assignment. Also, we talked about use of sentinels to terminate loops. In the sample code, we'll go over how to actually do this.